Hey guys, ScannerDanner here with my son Caleb behind the camera at my brother's shop. Got some SD merch on. Caleb and I are both wearing them, so pretty cool. You'll see those below this video if this ends up on YouTube. If you're on my premium, if this goes on the premium channel, you guys will know where to find it. This truck that we're working on is a 2008 Chevy Silverado, and I was just talking to my brother yesterday on the phone about this. And it's here for intermittent running issues, check engine light, and we have some history because my brother was playing around. It came into him with these two codes, an evap vent system performance. We're not worried about that one. That's for the evap system, Caleb, for your charcoal canister and all that. We're not worried about that. The main one is the 5-volt reference circuit 2 is setting a fault code, so that's a P0651. And from what my brother told me, when this acts up, the engine goes into a restricted throttle mode, which is pretty standard when you have a 5-volt reference circuit that's low, and one of the legs of that 5-volt ref feeds the APP sensor and the TPS, which is part of the throttle body. So it goes into like a reduced power mode, so you can't really drive it. The throttle plate's fixed. And then what he noticed when he got it to do it yesterday is his RPM disappeared. So he had no RPM signal, yet the engine was still running. So that leads us to believe that this system can run without the crank sensor. The crank sensor is also on this 5-volt reference 2 circuit. So we are concerned about a short in the 5-volt reference 2 circuit. There are 2 5-volt regulators on this model, and that's where we are. The throttle body was replaced, the crank sensor was replaced, the cam sensor was replaced, and the cam actuator, and the APP code that you see in this image was actually set by my brother unplugging the APP sensor with the key on, so that code, ignore that one. And then when I scanned it today, I'm getting we haven't even really started it yet, just turned the key on. I do have a crankshaft position sensor code. So our suspicions are that we have a wire, part of this 5-volt reference 2 circuit, that's touching ground, and our concern is that it might be in the starter area, which is the wiring to the crank sensor, which means the starter has to come out just to do a wiring inspection down there. So we're hoping we don't have to go that route. The other bad thing of where we are right now is my brother was pulling on the harness yesterday, and now it doesn't do it. He was able to duplicate this fault by having the engine running, and then he did a brake torque, which is foot on the brake, foot on the gas, and then he got it to act up. And when he called the customer, today he called the customer because we're having a hard time duplicating it. The customer told him he lives 4 miles from here and he never gets home without it acting up, like for that distance. So it's a very frequent occurrence, but he had the customer come today and drive it and it didn't act up. So what's that tell us? That tells us that when my brother moved the harness, we fixed the problem. And that's a warning to you guys too about moving harnesses. Now, he didn't do anything wrong. I do the same. We have to move them once we visualize the contact points. But the point I want to remind you guys of is make sure that you do visual contact point inspections first before you start pulling on a harness. Because once you start pulling on harnesses, you don't know where it used to sit. And finding that wire that's just barely touching ground can be really, really difficult, if not impossible, to locate. So that's where we are. I don't know how this is going to go. I think step one, what I'd like to do is, I know we have a crank sensor code, we'll look at that, but step one is I think I want to pull up the 5-volt reference 2 circuit and see what all was on that, so we get a good baseline of where we're going, what parts of the harness we're going to inspect. And then the second part would be the fact that my brother yesterday saw the car running with no RPM signal makes me want to do some scope test on the crank sensor, both on the reference wire and on the signal, just so we can see what's going on there. And I think we'll do that at the computer because of the location of the crank sensor, which Danner said can't get to it with the starter there. So I think up top we'll do that. So that's the plan, and then we'll cross our fingers that we can make this thing act up, okay? So 2 regulators on this, a little bit different than some of the older ones where you have 1 regulator where a 5-volt ref shorts out, it takes everything down. This one's 2, and it takes out half the circuit. I have a video on a 2 regulator system with a short that I'll reference here. It's on a Cadillac, so you guys can watch that one. Very, very similar type of approach, I think, with this truck. Wiring diagram. So Caleb and I are gonna review this wiring diagram with you guys on this 5-volt ref 2 circuit. And one thing is you see us both wearing our SD shirts. That these are the premium ones, not the tri-blend ones that we're both wearing. And just want to remind you guys that all the proceeds for our merchandise are going to charity. So we're not keeping any of it. Support the cause, sport your ScannerDanner shirt, know that the proceeds go to charity. So thanks, guys. Engine performance, it's a 6-liter VIN K. So there's 5-volt ref 1. You see where it says 5-volt ref 1 right there? I did not want to do that. We want 5-volt ref 2. All right, 5-volt ref 2, white black. Nice thing about the newer Mitchell diagrams is it'll keep that highlighted on the next page. You see it goes down to right to the...
Come on, man.
Well, it's nice that they make them highlighted like this. The problem now is if I touch like on the mass airflow sensor,
It'll highlight all of it.
It highlights all of it. Like that's cool and not cool at the same time. But that leg of the 5-volt ref 2 goes right to half of the accelerator pedal position circuit. Okay, so that's a designated wire, goes right to that, but there's more to this 5-volt ref circuit. They're internally connected as well, so we need to go to the other half of the computer, diagram 4, and we should have some other ref 2, yeah, right here, reference 2, reference 2. So it can be misleading. You look at that and you say to yourself, well, that's designated wires for the reference circuit. But what it is, guys, is let's say we have 5 wires going in that say ref 2. There's only 1 regulator for that would be shared internally. So on the older cars, it wasn't like that. You'd only have 1 wire coming from the computer that was a reference wire, then it would split externally. They're not doing that on newer systems. They're sharing it internally, making it look like they're all separate 5-volt regulators, and they're not. So ref 2, these are all part of the same circuit. You see it goes to half of the TPS as well. Okay, throttle body. Those are wiring diagram symbols for potentiometers. And when you see the resistor and a wiper, that's what that is. So that reference is feeding, sorry, not half, it's both. See inside? The split right there on the splice?
Yeah.
Goes over, feeds that resistor and feeds this one. So it feeds both sides of the TPS. The throttle body is new. So throttle body, half the APP. This is probably crank sensors is my guess. We'll follow that in a second. Let me just look down the line, make sure we don't have any other ref 2 legs of this circuit. All right, so see 5-volt ref 1, different regulator, 2 different regulators. We're not worried about
ref.
We're not worried about ref 1. Why are we worried about ref 2? Because that was the code we had was for TPS or for reference 2 circuit. Okay, so ref 1. So we're just looking for low ref. Not worried about that. Low ref. Yeah, I think we got everything. We'll make sure one more time.
Yeah, I don't see it.
All right, so we have 2 on this page. We know where the other one went. It went to the APP sensor. You see this leg going to the TPS, and then this leg we need to follow. Again, I touched that by accident. So that's 25 on page 4. It should stay highlighted. I definitely like that feature of the new diagrams. Yep, see it stays highlighted? That's pretty sweet. And there it is, crank sensor. Okay, all right, one more thing, just to make sure we didn't miss anything. Let's go back to the first page, which is the other half of the engine computer. And let's look at this and make sure I didn't miss a 5-volt ref 2. There's ref 1, 5-volt ref AC. Oh, it has 3. It's got 3. It's got its own maybe for the AC system. That's interesting. Ref 1, ref 2. The only one I saw was that white black, and that one goes to our APP sensor. That's accelerator pedal, gas pedal. Okay, so we've confirmed half of the APP sensor uses the ref 2, both legs of the TPS, that's in the throttle body, and then the crank sensor. So our harness inspection is going to involve looking closely at the harness that goes to the throttle body, looking close at the harness that goes to the crank sensor, and then the APP sensor that's inside the truck. Given heat and vibration, deductive reasoning, where do we start? Do we start inside the car where there's no heat and it's a nice comfy place? Or do we start out here under the hood where there's lots of heat, vibration, debris? Yeah, absolutely under the hood. I'm not gonna inspect the APP first. I mean, even though that's probably an easy inspection to take a look, I wouldn't start there normally. Make sense?
Yep.
So I honestly, the highly suspect area is the crank sensor. Given also that we had a no RPM signal and stuff like that when Danner was messing around with it. So visual inspection is what we're doing first. I'm not doing anything else but a visual first.
Okay.
Right, so it's just those 3 components. Why do I feel like I'm missing one? APP, half of it. Oh, because I'm counting the TPS as 2. There's only 3 components here.
Yeah.
Accelerator pedal, TPS, crank sensor. Contact points, Caleb. But my brother was in here with his meat hooks pulling things around. Just taking this air intake tube off.
When you do get the, if you're going to back probe at the computer, I'll go under there and move that harness around.
Okay.
See if
We were just making fun of you.
Well, I have a permanent kick me sign.
I was saying that you should.
I heard you. Don't touch the damn harness.
Yes.
You're like, look at the contact. I heard you in there.
Okay.
You were gentle though. So.
Look at your contact points, Danner.
I know where it's at. That's why I said I'll lay under there and wiggle it.
Okay. All right, so quick lesson on contact points, and I've done this before, but look, this is one of the sensors is the TPS. So there would be a contact point right at this harness here. I know it's not really touching, but that's what I'm looking for. Contact points. Where is it possible a harness can rub? So that would be one. I mean, not really, that's just easy to show you. So I want to look at this harness close. It's laying right on top of this spark plug. This harness here, follow the screwdriver. It's touching the spark plug boot on that one. Over here, touching the boot on this one. Not necessarily a bad thing, could be. I'm worried about short to ground, not touching a rubber contact of a spark plug. Right here, I got a contact point on this ignition coil, right there on that harness. So that's the same harness. Where does it go from there? It comes up into this guy. This is a plastic intake, so I'm not necessarily worried about contact points there, but I do have a contact point right here on this fuel line. Same harness, see right there? Mm-hmm. So that, once you identify the contact point, then you lift it up out of the way, take a look, see if the tape's damaged. It's not, so that's fine. These contact points here, I want to look at close. That looks okay. A lot of heat in these areas, as noted by this. Ready? Watch, watch. right? Lots of heat there. Now that is a main battery cable, but the same heat that did this to that, this harness is in that same heat. But all this looks good up here. I don't see any issues at all. From here, it goes into this harness, which runs its way back to the engine computer. So we're gonna do some inspection over that way now before we go underneath to the crank sensor, because it would actually split here. See, and I don't know if that's maybe where the crank sensor wires, which is this harness back here. I don't know if my brother pulled the conduit off of this part. Looks like that was bolted up too. Somebody took that off. That harness is loose down there. I definitely want to look down that way. What color was our wire? We never mentioned it.
Yeah, you never mentioned it.
So the one that goes to the crank sensor is purple and white. The one that goes to the throttle body is gray. There's a purple white wire right here. It wouldn't be the twisted pair, Caleb. Those stay together to a different sensor. There's a gray with a black tracer. There's a gray with a white tracer. So the TPS wires do not go in here. They'd come down. Here's my engine computer right here. So the TPS wires would go into this harness and they would run down this one, and then they would go to that guy right there. So I believe that maybe the crank wires, it might come out this way, and this could be my reference to my crank sensor right there, which is the purple white. Let's do a quick voltage measurement on that. Be right back. As far as approach to this, it's hard for me sometimes to, in a case like this, because there's information that I received before I got here, it's hard for me to convey to you guys on where to begin. If you were to face this problem and you had no history, where would you begin? The car comes in with a code, P0651 5-volt reference 2 circuit. That's what the car came in with. What do? Exactly what we're doing. Without the history, I would be doing the exact same thing, looking to see what all is on the 5-volt reference 2 circuit, doing a visual inspection, and going from there. Of course, driving it, recreating the problem, you know, all the stuff that happened in hindsight, noticing the RPM was dropping out, the crank sensor signal is suspect, all of these things than you would do after. But the approach that we are doing right now, what we're doing right now, would be no different had we had no symptoms at all. I'd be doing the same thing. And I would absolutely be suspecting the crank sensor area more than any of these others because of where it lives. So right now what I'm doing, I just want to see if this purple white wire right here is a 5-volt ref wire, and that'll give me confirmation that that's most likely my crank sensor wiring. The other thing, as I'm viewing this crank sensor, I should have in this same harness right here, these same colors. So I have a purple white. Do I have a white and black in here? There's a white with a black. And do I have a gray black? There's gray black. So all the wires for my crank sensor are absolutely in this harness right here. So this should be that should be a ref. Phil's probe. It sounds kind of odd to say that I love Phil's probe. Ah, this one's different than my other one. That one's different. Why is that not? Huh. Hang on a second. They did redesign it. They did redesign it. top of the probe is different. So it was redesigned, and the one that I was thinking I wanted to use was this one because my lead goes right over top of it, where the older design didn't do that. So nice job, Phil, on the upgrade. So if this goes on YouTube, this will be the point where people say, what do you need a lab scope for? I'm just using the meter, okay? And I have a desktop recording going. I have the key on. It would help if I connected my ground to my... There we go, 5 volts. So this will be the one that we want to watch, Caleb, whenever we start wiggling some wiring. Actually, what I want to do for this, I actually want to use my graphing meter, because then I don't have to worry about sample rate and time base. I can pick any time base that I want and it will not miss the glitch.
Are we trying to see if it's like shorted or anything?
Yeah, so when I go under, I'm gonna start wiggling some wiring and do some visual inspections underneath. We're gonna watch that signal right there when we're doing it. So contact points again. Let me get my flashlight. All right, I'm going underneath. I'm gonna check this harness. Did Danner say I thought he said the starter was in the way. Or is that the cam sensor maybe? What am I looking at here? I see some new components, that's for sure. All right, keep an eye on that. Actually, yeah.
What do you want me to do?
Watch the 5 volt line on that. Tell me if you see any changes.
One sec. Okay, I'm watching.
I don't know, what component is this? It sure as hell looks like the crank sensor. Keep watching it.
Yep. Steady.
Okay. That is the cam sensor. It looked like the crank because it was right above the harmonic balancer, but that is going into something above that. That must be the cam sensor, because I got multiple wires that go to that too. Yeah, you see all the wires that are on this connector, so that is not. Wait, there is a purple white wire there. I need to look at the cam sensor wiring real quick. There's a purple white wire that went to the what I believe is the cam sensor. I just want to see if that is the case. It says right rear of engine. So what is that? I need to talk to Danner real quick. Danner!
Yeah.
You said the crank sensors. Okay, underneath on the harmonic balancer is a new piece.
That's the part going to the VVT or the cam phaser that's behind the water pump on some of those new LS engines.
So that's not the cam sensor. That's just the VVT mechanism.
I believe so. Maybe the sensor's built into that because there's a bunch of wires.
It's got like 5 or 6 wires going to it.
There's a solenoid on some of the newer ones that go behind the water pump that do the variable valve stuff, but I haven't messed with those yet. But that wasn't on that circuit too. Okay,
no, it's got a purple white wire going to that, which is the ref circuit. That's why I was...
Yeah, no, the crank sensor's above the starter.
Okay.
So if you follow that wiring through the plastic, go above the starter, and then there's a shielded piece about that long.
All right.
And it was like touching the...
All right. Okay, come on. Ooh. Valve, lifter, oil, manifold, assembly below the intake. What the hell? What is this mechanism? I need to know what I'm looking at. It says cam sensors, front of engine above crank pulley, but it's only got 3 wires. There's more than that. Okay, I'm just gonna keep looking because that's not helping me. I'm not worried about what I saw right there right now. I'm gonna go back underneath. Caleb, you can maybe mount the camera and be my 5 volt reference watcher as I'm moving the harness. Okay, so our concern here, my concern after seeing this purple white wire on this connector here, if that's even purple white, let's see. Oh, that's a solid purple, it's not purple white. Okay, so the wire colors for the cam sensor, read them to me, Caleb.
Dark blue.
Yep.
Dark blue with white.
Yep.
And brown.
All right, so there's a dark blue, white, the middle, that guy's brown, and then dark blue, and then the other two wires would be for the solenoid. So this would be my cam sensor and cam phaser. We can try to locate those colors on the diagram later. Not important, this is not our guy. We need to follow this harness, one that comes from up top. Although there's a rub mark right there. Hold on a second. Right there.
Stay there, I can see that. I'm gonna get it.
No, I got it. I got it.
Are you sure?
Uh-huh.
I had a good angle.
No, I'm good. There's no all right, nothing on that. But that's my harness we want to follow, and that goes under the pulley and then goes over that way. So I'm going to go on the other side of the truck now. All right, so that's the harness that comes up the side of the block, and then that's the wire that Danner had mentioned that he wiggled. All right, watch it, Caleb.
Watch it.
See if there's any damage on this. I don't see any damage to this. Nothing, huh?
Nothing.
Staying steady. I'm just wiggling the computer harness. I might have found it. Contact points. So check this out, right? You look at harnesses. You wouldn't really think that's a contact point right there, right?
With that little
bolt, right? There's a hole in this harness, right? Right there. Hold on, before I move anything, it's all the way through the conduit. Right there, right? Now let's walk, well, you stay focused here.
Yeah,
I'm gonna see if I can short this reference. See if we can make this thing do it. I mean, I haven't looked yet. It might be not in the right area. But dude, there is a hole in that harness. See the hole?
Yeah.
See the hole?
Big hole.
That's a big hole. Okay, I'm pulling that. That is worthy of pulling apart. I really think this is it. Some of this work that we do doesn't have to be super complicated and complex. It's a basic system. It's a 5-volt regulated circuit with a short to ground. Do some harness inspections, and that, let me see if I can turn this around. See, when you move harnesses, oh, there's a purple white wire right there.
Yep.
See if you get a shot before I pull this apart. That purple white wire is right there. Contact points, and look where it was contacting. Right there. Right there. No wonder Danner couldn't duplicate the fault after he moved the harness. All right, I'm gonna open it up. No question, boys and girls, this is our problem. No question about it. Oh my goodness, it's so small. Look at the rub. Oh, that's about as small as I've seen. Hold on. I don't want to. Now, I wouldn't normally do it like this. Just so we're clear, I want you guys to see the natural state of that purple wire. I don't think your camera's gonna show this.
Oh, that
right,
little reflection. All right, don't.
There's copper wire right on top of my razor blade. Can you see it?
Yeah.
You're gonna have to move.
Just focus it right. I have it. Just don't move.
Hey, Danner, check this out, man.
Hey, he wanted to.
That'll be $100.
That's it. You fix it.
Come over on this side. This will be $100.
$100?
Yeah, I'm just kidding. I don't charge my brother anything. Do you see the copper wire sticking through the purple-white wire right there?
I see the white line missing from the section of, yeah, where was that hitting?
Right on this stud right here.
No bleep.
Yeah. Yep.
Wow.
Yep.
And is that the reference?
That's my reference circuit. So what I'll do is I'll intentionally short that to ground.
I'm wondering why, real quick, while we're talking.
That goes to the crank sensor.
Well, even if it doesn't matter though, if that's that same 5-volt 2 circuit, right?
It is the same 5-volt 2 circuit.
Doesn't matter because they change wire cut because there's 3 different pins that come off of the computer as 5-volt.
Right. And I was trying to explain that to everyone that even though it's like that,
it's still an
internal shared circuit.
Here's my question, right? So every time he's had this happen, he's had the 615, whatever code it was we're looking for.
It was the 651.
651.
Yeah.
Because remember I called you and I was like, I did not have a crank sensor code, but I think that crank sensor code might have set maybe when I cleared the codes while it was running to get throttle response back, and then I realized I had no RPM, and at that point we were in no RPM.
Let's catch everyone up on what we're talking about. So listen, on the phone yesterday as I'm talking to Danner, we were debating on this 651 code. We both knew, and now you guys know, that the 651 code is a 5-volt reference 2 circuit that also feeds the crank sensor. So the question that Danner and I had was, well, he was looking at the 5-volt ref 2 on the scan tool and it never dropped, but he had no RPM signal coming from the crank. So that's what we're talking about right now. And what I thought was, maybe the logic on this computer is one where when we have a reference 2 fault, the computer's going to disable the crank sensor code setting enable criteria. That's my guess on why we didn't have.
He would disconnect the battery every time it would quit running. And
Danner's question was, how do we have a no RPM on the scan tool? How's the engine run with no crank signal? One is it probably is able to run with the cam alone.
Long crank time. You know
long crank time. But 2 was, why are we not setting the crank sensor fault when we have no RPM signal? And I believe the answer lies in this 651 code. And what Danner had just said is he had cleared the codes with it running, and that's where we think maybe we finally got a crank sensor code now because we had a...
Yeah, the 5-volt didn't crash at that point, and maybe, you know, like you said, maybe it's not.
Well, we could try to duplicate that. I can short the reference circuit out and watch what happens, but
gotta do it.
I'm going to. That's going to happen. All right, so as we're shooting this today is what, 26th of August, I think. And I have a class coming up that Caleb is actually editing right now that we'll have part 1 and 2 out this week, where I'm really talking about the reference circuit and protecting it using a test light and the amperage involved with the reference circuit. And this is a lesson for that video, for that class, to say these are pretty well protected circuits. That circuit was shorting to ground. I'm going to show you right now that exact short, and I'm not going to hurt it any more than what was already done is my point, okay? So, we'll ground it. Contact points. Good lesson on contact points, huh, Caleb?
Yeah.
So, we'll watch the scope. There's my drop. Just touching that. All right. And then scan data. We should be able to see that on the scan tool too. There's my ref 1 and ref 2 circuits. So what Danner had mentioned is he was not able to see ref 2 drop out on the scan tool. There it is. So it certainly does. That's pretty cool.
Was that in a loom?
Yes.
Is that an aluminum that would have kept it there most of the time?
Yep.
Like tugging or nothing, it would have been
It was
there?
literally sitting, come over here on to the right of Caleb, I'll show you. Now I have the whole, you know, it's exposed now, but it was literally, this stud was literally inside of that harness. So it was, was sitting right next to it, and you can see it's all worn down. So it literally
What made you even look there?
Well, because
it was stuck inside the harness.
Because I looked at the crank underneath.
I never took the cover off last night. Yeah.
But I looked at the crank underneath, and the
looked good. The shielded
the
wire.
shielded looked fine. Like I spun it all the way around, and I'm like, and so I don't know why I grabbed that harness again. I just was kind of looking at contact points
why
again.
Is that stuck there?
Yeah, pretty much. And I don't know if we had the camera on it whenever I was pulling there.
I was moving over towards you.
Yeah, so I think we missed that.
Is there two?
I think you caught my face though, because I was like, oh.
Are there two there to where, or like, would it maybe just disable the crank signal? Like, why did I have still a good 5 volt?
I don't know. Look, here's reference 2, right?
And I even back probed it at the APP. You know what I mean? Well, just to make sure that it was still there. Had 5 volts, and I still had no crank signal.
Well, it could be that you did have a crank signal, and maybe the scan tool wasn't updating it after it set the fault.
The TAC didn't work either.
Well, let's do it. Let's sort it out and see what happens to answer that question. But I mean, to watch the scanner though. What? See it? See the glitch? See the drop?
Yeah.
But I mean, it's possible that with it running.
I don't know. I even shut it off and started it back up, and I still had no RPM and a long crank time. And then it was like 10 minutes later before it decided it was going to work.
And you were saying that during that condition, you absolutely verified Ref 2 was good
at the APP, because I was able to back probe that easy, and it was the same circuit. So I thought if that's
but it wasn't ScanData you were looking at. You were literally looking at APP. Are you sure you were on the right wire?
Because there's 2 of them. I don't know. I think I followed the wire color though.
Do you remember which color you were attached to?
Whatever it said on the flow chart for that. So I probably was on the right wire.
Because APP2
has both. One leg is sensor or reference 1, and one is reference 2. Let me get this.
Here, we can redo that test right now.
Yeah. There you go.
Ooh.
What was that click?
Computer not liking us shorting the reference circuit out. While we're waiting on Danner here, guys, all I'm doing is just shorting the reference circuit out and watching it on the scan tool. We had some things that clicked at us. Caleb was like, what's that? That's just, we're sorting out a 5-volt reference circuit, is what we're doing. And I realize some of you are cringing as you're watching me do this. And I am too, in a sense. But keep in mind how long this reference circuit has been shorting to ground directly. I'm not concerned about me shorting it some more to prove what it was doing, okay? I wouldn't normally recommend directly shorting a 5-volt reference circuit out, but this is something that's been ongoing, and I'm totally fine with what we're doing. I just need to recreate it for you guys, that's all. The more I mess with this, the more copper wire you can now see. All right, so let's, so this is a MAF engine. One of the things that you want to do when you have a mass airflow engine and you want to run the car without putting the air tube back on is you want to unplug the mass airflow sensor, because that'll put it into a default strategy on most cars. But in our case, this is not in the way. I'm just going to put the air intake tube back on. Mainly because what I'm trying to do right now is answer my brother's questions. He has some legit questions on what he was seeing, and we're going to try to answer those for him. Just some computer strategy type stuff. So this is a good lesson, Caleb, on don't be a parts changer, don't you think? It's got a new throttle body. It's got a new cam sensor actuator. What else was going to be thrown at it new before they decided, you know what? It's time to pay a diagnostic fee. For those of you that think you can just hook a scan tool up, read a fault code, and change a part This is a great lesson on that. What fault code do we have in our scan tool when I started? When I started today, the code we have is a random misfire code. What's the parts store gonna sell you for a random misfire? Plugs, wires, coils. Okay?
Close to what you need.
Not even close to what we need. Part 2 of this, we have a crank sensor fault code. What's the parts store gonna sell you?
Crank sensor.
Crank sensor. Guess what? Don't need a crank sensor either. What's the problem? Shorted 5-volt reference circuit. You just can't do troubleshooting that way. I'm really getting frustrated by the market as a whole in general and the way that they've kind of created the problem themselves, you know, that our parts stores who supply us with what we need to fix this promote code reading, parts changing. And there's even commercials on YouTube, on my own videos, that like fix it or fix ya or some stupid Bluetooth piece that they just rip on mechanics like we're out to rip people off. And here, this device is gonna save you money and it's gonna tell you what you need. It's a bullshit commercial. You can't change a part on a code. Don't be a parts changer. 5-volt reference circuit, shorted to ground, shutting this freaking engine off. Here, let's do this running now, see how it reacts. We'll clear codes first, get rid of all our codes. All right. All right, so the first thing we'll do, we'll short this and watch the code. No, we'll come back to the code. Let's get the scan data up. Try to recreate what my brother was talking about. I was under TAC data, I think, for my reference wires. Ref 1, Ref 2. Ignore those spikes. There's nothing wrong with that. It's a min-max scale issue. See, I don't have RPM in here, but let's do the test. Short out the ref.
Whoa.
Engine stalled. And if I don't turn the key off, it should have a reduced power mode right now.
That was sick. That cut out right away.
That's because it feeds the crank sensor. Long crank time.
Yeah, low. You can hear it.
It doesn't even run.
Stalled out.
We've definitely duplicated the complaint. As long as I don't turn the key off, then it should stay in this reduced power mode, which actually says yes right here on the scan tool, right below the graph, Caleb. So when you're editing this, reduced power says yes. Here, keep this running for me because I just shorted it. I'm in a reduced power mode right now. Don't turn the key off. And what I want to see is if I have, that's what we have. No, I want to see if we have no RPM signal. Hold on one second. Okay, good. No RPM signal.
Wonder why it's dying now.
Because
he did say sometimes it wouldn't start.
Because I shorted the reference circuit out, and can you keep it running with your foot on the pedal? Okay, so we have no RPM signal. Exactly what you duplicate, or what you said. Yeah. Code-wise, let me just see what codes we have, because I cleared them before I started.
Well, like I said, he was just.
Yep, just have the 651 code.
See,
I have no crank sensor fault.
Yeah.
I believe that our crank signal's fine, and the reason it's doing that is computer logic. This is a logic fault right now.
Okay.
So
I'm wondering why it doesn't run, because yesterday I cranked long.
well, here we can do this. We can do this. The crank signal wires, that's my reference.
Yeah.
The crank wire, my other two crank wires were white, black, and gray. Let's get the white, black. I think that might be the signal. Let's show that.
They have like teeny little fingers.
Yes.
Or one Piers.
Teeny little ones.
Yeah.
It's freaking sweet.
That is nice.
All right, start this up for me. Well, I mean, you know.
You should see a 6.
Yeah. If I'm on the right wire. Yeah.
No TAC, but
Yeah, and I got a perfect crank signal.
Okay.
Hang on 1 second. So you have no TAC. Get a shot of that, Caleb, the no tachometer.
Yeah.
So no needle movement, no tachometer movement. Before we turn the key off, again, guys, we're still in a default mode for me shorting that reference circuit. I just think
clear that code, it's gonna probably.
I know, and I think the computer is just like locking all this stuff out, including sending a message for the TAC and crank sensor signal updating on the scan tool.
Yeah.
It goes to show you can't rely on scan data.
No.
100%. We got no TAC signal.
That's why I probed that 5 reference over here, because I'm like, it's showing it, but it's not running, and I have no.
So that makes sense. So this connecting the dots here, guys. When Danner checked the reference at the APP, he was on the correct wire. We're assuming he was on the correct wire.
I looked at the wiring diagram.
And the question that he had, which was legit, is why is this thing running this way when I have a good reference, when my only code is for low reference? Why do I have no tachometer? Why do I have no RPM? We've just duplicated that by me touching that reference to ground. One more piece for everyone else. I want them to see a good lab scope signal. I was on the graphing meter before. I'm now on the lab scope, which will show us a much clearer picture of this crank sensor. Go ahead and start that, or start, run, stall it. Cool. Now here, Danner, come out and look at this crank signal. It's perfect.
Oh yeah.
So just go through there's nothing wrong with that crank signal at all. And there, we should have an RPM signal. Let's go back to the scanner and show that we don't have an RPM signal.
Yeah, because it won't show up.
And what I'll do too is I'll take the data list and we'll get rid of everything else just to make sure that we're speeding up this process. Let's see the counter down there?
Yes.
So wait, hold on. I want to see if it's any faster. These newer ones, sometimes it's not. Let's watch the counter.
No, it's not counting at all.
Come on. There we go. So it didn't change. So limiting my data PID, see all the counter?
Oh, okay.
So,
you're looking for refresh.
Yeah, so I don't need.
You should, while you're here, look at that one.
The Volkswagen?
Yeah,
no,
come on, man.
no.
I just want you to graph the crank sensor.
Here.
I have a code for that.
All right, maybe. All right, so watching our RPM, go ahead. No RPM signal at all. All right, so without clearing the code now, what we want to do, we're going to turn the key off. Caleb, we're going to come back over here and get a shot of the tachometer.
See, but it didn't come back immediately for me either.
With the key off. Wait 10 seconds, 15 seconds. You might not have waited long enough.
Maybe, because I had talked to a customer for 20 minutes.
You know what else I found? Wait, hold on, time out. As I was building the class that I did, Caleb, with my truck, 2009 version of this, as long as I had the scan tool on there, with the key off,
stayed awake.
It kept everything awake.
Yeah, I ran into that on an anti-lock brake.
And so
I was looking for. I'm like, why is this still showing?
Stayed awake because
it was like
scan tool.
5 minutes. Yeah. Someone that saw the video was like, oh, well, you had the scanner plugged in. It stayed awake.
So watch when I go out of. So I still have data. You have the key off, right?
Yeah.
I'm not losing data.
Yeah.
And if I exit out of here and then go back into engine data, it's gonna say, nope, it's still talking. Hold on. Let me exit out again. Let's go back.
Or do we got to disconnect?
No, let me see. Let me go back into the engine again. Still talking. So if I stop talking to the vehicle altogether, all right, so no active vehicle. Now if I go vehicle history and activate this, again, key's been off the whole time. 2008. No, now I have attempting, it actually ID'd it. The key's still off, right?
Yeah, it's in my hand. Right?
Codes menu, no comp.
No comp.
Yep.
Okay.
So now,
maybe it'll
without clearing the codes, no, turn the key on so I can get data back. Okay, without clearing the codes, we're going to retry our communication. Yeah, there's our 5-volt ref short code. And I believe, though, that's the answer in why, even with the key off, you couldn't get this thing to...
Yeah, my
because your scanner's still keeping it alive. So there's my engine RPM. Let's get a shot of the TAC, Caleb, for this test.
All right, go ahead.
Bam.
And I have, the TAC's there, okay.
So I believe we answered all your questions. Why turning the key off didn't fix it for you because you still had your scan tool on. It was still talking. So remember that when it comes to CAN systems, that the scan tool becomes a node on the network that's still talking, and it's saying to the rest of the network, okay, we'll stay alive. And I ran into that playing around with my truck.
For a key off current draw with your scanner still hooked up?
I think I did. No, I was looking for a short to ground, and it was affecting my test. But
Nice.
So I think we answered the questions, which is how come we can have a good crank signal and have no RPM is the computer goes into a mode where it says, I know that I just lost my crank signal, my 5-volt ref circuit's down. In fact, that we just proved that it's not going to set a crank sensor fault with that 5-volt ref.
And that's why I probably said it, because I cleared it with it running. That makes total sense. That's awesome.
I don't know about that part.
What's that?
Leave it run for a second. I'm going to do that one more time because that was fun. Caleb liked it too.
Okay, so you want to try to clear the code. Well, see, but I lost ATP because he would say the check engine light would come on, it would still run for a while, and then it would crash, and then he couldn't do anything. And sometimes it would start back up and run really bad. So it was always, it wasn't exactly the same as far as what it did. Like for me, it always started and ran, but if I took it up past 2,000 RPM, it would fall on its face like it was running out of fuel. And he said, yeah, sometimes I can limp it, sometimes I got to disconnect the battery for a couple minutes until I can get it to actually start. Sometimes no start, sometimes
I think it could all be in how much that reference circuit's shorting out. Like to what level? Is it pulling it all the way down, how the computer reacts to that, to where it does if it pulls down to 2 volts. There's one more piece I wanted to address and I forget.
You wanted to try
the code, the crank sensor fault.
See, we cleared that code. See, that's weird. I don't know why, because the crank sensor was working, and you don't see any other.
You know what? I need to open that up to look closer to make sure that we don't have, because there is absolutely rub marks.
So maybe it was hitting both of them. Maybe that was short to the crank sensor code or wire. I don't know.
I mean, I don't see another wire, Danner, but I'm going to pull that apart to look. Oh no, it is. The blue with the light blue with the white was out. No, was not one of our crank wires.
Dark blue with the white.
There's a light blue with the white that's also got a rub mark on it. See the corner of that?
Yeah. That might be dark blue.
But the crank sensor wire
darker than his light.
But the crank sensor wires are gray, black, white, and purple white. So that blue wire right there where my pinky is, where we see a rub mark, that's not even my crank sensor circuit. I don't know why that would.
I want to take a picture of that before you open it up.
Okay. Well, I'm going to short it too. Shorted reference coming up. Ready? Now it's running crappy. Different reaction that time. Hey, we have a misfire now and it's running. After I just briefly touched it that time.
That's what happened. That's what happened.
And look, no RPM signal. And I bet my TAC's at 0.
Yeah, exactly. That's exactly what's happening.
Let's get a code here. There's our ref circuit code. Yes, I'm doing it. So the only code we had was ref. Let's see if this sets like a crank sensor fault. It just started running good. As soon as I cleared that fault, obviously this is a strategy issue. What the computer does when that 5-volt ref circuit shorts, we can speculate all day long. I'm not the engineer. I didn't write the coding. I didn't write the software for this. Absolutely, that's our fault.
Totally proved everything.
Yep.
This is our YouTube.
Learn your fundamentals, people. Right? This stuff is not hard. 5-volt reference circuit. You want more training on a 5-volt reference, how it operates, what to look for? ScannerDanner Premium, Chapter 9, Chapter 10, great chapters dealing with a 5-volt reference. Also, actually, Chapters 6, 7, and 8 on thermistors, potentiometers, pressure sensors, how everything's connected, how you can have one wire touching ground that affects the whole circuit. Man, this is all fundamentals, guys. This is not hard stuff. The last part of this, we need to open that up, make sure we have no other wires that are damaged, and then we need to repair this circuit, which is really going to involve some either clear nail polish, liquid tape, and then some tested tape over top of that. And then we need to make sure we have this harness pulled up away from that stud. This was...
So did you get it to act up before you start messing with it, or you just start looking at the circuit?
I didn't, we did not get it to act up at all before we started playing around.
Okay.
So, and I was just telling our community that, you know, some of this stuff, when you don't have options on where to go, is the visual inspection's everything. And sometimes we forget that.
Yeah.
As professionals, sometimes we want to go
just like when
scan tool, scope, and, you know, do your visual inspection.
Well, when you're sitting here talking to him about me touching the harness, I mean, how many times have you been there though when someone started doing something and you're like, well, I don't know.
Yep.
You know, you tugged on something and it, you know, you could have moved stuff out of the way. It could never. It might take you know, weeks to break it.
Yeah, exactly. I want to show the small holes, Caleb, that this Phil's probe leaves. Here, come here.
Yeah.
What's that, Danner?
Do you ever like put like super glue or anything on those little...
To be honest with you, these holes are so small, I don't even worry about it.
I got that.
But we'll, just to keep everyone happy, all the anti-pokey people who lie anyway, they all poke wires. They just don't want to tell anybody they do. Or the ones that don't poke wires are the ones that like to roll the dice at a certain point in a diagnostic.
Because you don't want to poke
you don't want to poke the wire, and so you put a part in it.
I'll usually just like use super glue or something if I gotta poke one.
So all we'll do with that, those little tiny holes, so we had one there and one there. Done.
So you're going to open that harness up, cut that tape back?
Absolutely, I need to. But I want to be careful in how I do it because...
You want to see where everything lays.
Yes.
There's like...
And that's the key with recreating this. You really want to... you don't want to get too aggressive because I just wiped it. I should have did that after. I'm going to get a comment about that. Hey, dumbass, you just wiped the stuff you just put on there. I know, I see it. That's the difference sometimes with teaching as you're filming instead of doing. I would have waited till I was done to do that part. You can see where it was rubbing. You see the other wires that have some rub marks on them. This blue-white right here. It didn't poke through that one. Yeah, another purple white. Didn't rub all the way through that one. Just so happened to be the one reference wire. You can see though that it definitely was rubbing through. There's a 2-wire sensor. Might be a rub mark on that one. What do you think? Did that make it through that? The twisted pair wire?
Look like it. It doesn't look like it went far enough in any of those.
Nope.
Just that one.
Just the one wire. Yep.
And it didn't even fray it, huh? It just
Just touched it. So there's no reason
to cut it. Yeah.
To cut it. I'm definitely gonna liquid tape that.
Then let it dry.
Let it dry. And this stuff dries pretty quick. We'll let that dry, and then I'll tuck that back in the harness. So we're using some tested tape, which is a very fibrous tape. Very much is going to be perfect for this application for what we're doing, just because of the strength of the tape. All right, so we need to get this up so it's not going to contact that again, because it will rest back in that spot. I don't know the best way to do this. Maybe
mean, this, you have engine movement, so this has to move. Maybe putting another piece of like rubber hose or something underneath that. It's like I don't want to tie it to these hydraulic lines because this engine's going to move. Let me get something from Danner. I'm stealing this. It's an old piece of a thermostatic air cleaner. I'm not even going to tell him I'm doing it. I'm just trying to add a little bit of extra protection, that's all. That's all I'm doing. And if it was a different harness somewhere else that was more stationary, I would tie it up with like a zip tie. But the reason that I'm not on this one is because that harness needs to move. The engine moves. It needs to move. So we'll just add a piece to it. In fact, I'll put the fold underneath, so it's got to go through two layers of this, and then like 3 or 4 layers of Tesa tape before it would ever do that again. I'm pretty comfortable with this. This truck will be in the junkyard before this happens again. Okay, we'll get the owner, bolt that back up to there where that ground is.
Mm-hmm. That's awesome, man.
Yeah, for sure, man. The cool part is
what sucks for him is he spent so much money on all the components.
Where did he have this before?
I think he was doing it himself.
Okay.
He's a alternator guy, rebuild stuff, so he's knowledgeable, you know what I mean? And they have scanners and nothing crazy, but
yeah.
I think he might have said he had seen a crank sensor code at one time, and he thought he saw a code for that solenoid underneath, and he had the misfire codes, and then the
misfire was weird.
He knew that the throttle body was on that circuit, so he had some stuff, but he wasn't able to go far enough with like what you did with strategy and why and that kind of stuff. So
it's just knowing. I mean, for this one, for you guys that are listening, this one's about a regulated circuit that's protected. They use a 5-volt regulator that has protection for amperage. And when it senses a short, it has a strategy that it just starts doing stuff. I mean, the protection part wasn't the misfire and stuff. I don't have an answer for that.
Yeah, that has to be like
if we would RPM, scope.
Why would it lose RPM? Like, you know what I mean?
The RPM was there.
Down when it was there.
Why is it shutting coils down and injectors down, or something with
or timing? Something. It could have just been timing, but whatever it is, the first time that happened, the engine was. I could hear like piston slap. It was misfiring so bad.
Yeah,
like,
for sure.
You know what I mean? Because it wasn't timing.
There are some other questions we could answer. We could scope all those other things and see what's actually being shut down, but that's not important. What's important for us and for you guys is to understand the relationship of that 5-volt reference and how important it is to the engine management system. Well, and what the computer will do.
If anything, you just showed don't go down that path because it's not going to lead you anywhere.
Yeah, follow your code. You got a reference circuit low code. So anything you see with 5-volt reference circuits, guys, are absolutely critical. I would put that above everything. Everything. If random misfire code, crank sensor code, coil codes, you name it. If I got a 5-volt reference code, where are we starting? Reference circuit. Another lesson. And this isn't Danner's fault at all, even though I was giving him shit about it. Don't pull on the harness until you visualize all your contact points. And that was one I missed too. In your defense, I did all my contact point recognition, and I never even bothered with that big one.
Is those the ones coming over to the throttle body? This blue, the one that shorted out, your purple white one.
Purple white is the one that goes down to the crank sensor.
So it comes up from the computer, comes up here and
Correct.
jumps and goes back down.
That's correct.
Okay.
Yep.
Okay.
Yep, that is my crank sensor 5-volt ref wire. And again, guys, internal to the computer, these are all connected. The ref 2 wires are all connected. So TPS 1 and 2, APP, half of it, APP2.
I think it was 2.
And then crank sensor, all 3 of those come into the computer, and they would plug,
Right.
say my hand's a regulator, they would plug in, or my thumb would be the 5-volt coming out. So you'd have 12-volt feed, ground, 5-volt coming out. Those 3 legs would plug in to the one regulator. Yes.
Regulator.
Yeah. Older cars, they would send one 5-volt ref wire out, and then they would split it and branch it. The newer cars are running them all back. So a lot of people think, oh, those are all separate 5-volt ref circuits. They're not. They're all the same. There's 2 on this truck, 1 and 2. Actually, there might be 3, because on the diagram it said AC compressor, AC something ref.
Yeah.
So there might actually be 3 on this one. As of today, which is 8/26/2019, there are over 400 videos on my website with hundreds and hundreds of hours of material. Half of them being classroom type lectures where I'm teaching you concepts. Like, you really would want to sit through my 5-volt reference class on this vehicle, on this setup. And then the rest of them are exclusive case studies that I only have on my premium channel, and we're constantly updating and uploading new case studies for you guys, and new classes. Got some new classes coming out actually this week. So hope to see you guys there. ScannerDanner Premium on my website. Guys, thank you so much for supporting me here on YouTube as well. And Caleb and I have no idea what I'm gonna say right there. That's awful. Brain fart. We have thankfulness in our hearts. No. I don't know where to recover from that.
I'm just gonna leave it in.
Are you? Fine.
Yeah,
we have.
We'll see you next time.
We have faith that you'll see us next time. We'll see you next time. I don't know.
Thanks for watching.
So thanks for joining us, guys. Special thanks to cameraman Caleb behind the scenes, of course, for his work. Make sure you guys thank him for his edits too. He's doing a great job for us. We'll see you next time.
I've been beating the crap out of it for 6 months on Manifold.
I love it. Look, there's so much. Well, there's some bias in here too. One of the things that I wanted to do in prepping for this class, I really wanted a part 2 for the bias class that you guys were part of. I really kind of wanted to build on that. I told Ed that up front, and then when he told me that that this was a new class, see, I was thinking this was week 5 after the summer break. And I didn't realize this is a new class. So you guys have only had 4 days of this. And so I kind of took a step back from that, and I said, well, I can still include bias in here, but I can show you a little bit on the input side. So we were on the output side when it came to bias voltage and recognizing circuit integrity, making sure wiring was good. And on this one, I'm focused more on the input side of the circuit. So sensor circuits and how we can accurately troubleshoot wiring problems, sensor problems, computer problems without having to follow a manufacturer flow chart. And so manufacturer flow charts, I know you guys have seen them, and they're difficult, and they're written in a way that I just spoke with a friend of mine yesterday who's real high up in the industry, and he's close to a lot of the engineers, and he's kind of corrected me a little bit on engineer bashing. I've been engineer bashing for like 25 years. I mean, I have been. I've been complaining about engineers this and engineers that, and not realizing that it's not even the engineers that are writing the flow charts. And the guys that are writing the flow charts don't even have access to the guys that built the car. Well, look, let's be honest. The stuff I'm going to teach you today, there are certain steps. If you do them wrong, you're going to hurt something. Okay? Because why am I teaching you this? Because I've been using these methods for 25 years, and they're tried and they're proven, and you won't hurt anything if you listen to me. okay? To mass produce something like that on paper, I think you miss a little bit of that. And I think in a situation like this, I can teach you these methods. We can know about the hazards, if you want to call them, and then you can choose what method you want to use. There's going to be times where you're absolutely going to want to use these methods, okay? All right, so you guys ready? So the idea of circuit integrity, we're on the input side. That's the plan. Input side of the circuit, we want to try to avoid having to be solely reliant on a manufacturer flow chart, okay? I think I prepped Ed a little bit about what I was going to be talking about. I'm not sure how well I did in that email. First thing I want you guys to remember is that the meter you're using, your voltmeter, has a certain resistance to it. And I was just explaining this to Caleb yesterday too. When we use a digital voltmeter, we want to make sure that we're not stealing voltage from the circuit we're trying to test, and that's the whole point. We want to make sure we're not stealing from that circuit. Let's say I'm measuring a 1 volt oxygen sensor signal, and it takes 0.2 of a volt just to run my meter. So that 1 volt signal, I drop down to 0.8 just by connecting my meter to it. That would be a bad thing, wouldn't you agree, as far as how the computer would use that sensor? So internal impedance of a meter is its resistance. And so all I'm showing here is the resistance of the, let's see which one I'm on. This one's set to volts DC, this one's set to ohms. So which meter am I measuring right now? I'm measuring the impedance of the red meter. I want to know how much resistance the voltmeter has on the red meter. I'll leave you guys with this, and then you guys go to your award ceremony, we'll pick this up when you come back. When we do measurements on a car, I want you guys to be able to recognize the signal circuit without having to look at a wiring diagram. So you're on the car and you see 3 wires and you're taking 3 different voltage measurements, and here's what you're going to see: 5, 5, and 0 say on this design. The meter you're using in particular will affect what you see on that guy.